Hey everybody and welcome. This is our introduction to databases lesson. To start off this journey of now that we've talked from client to server, how do we now talk from server to database, back to server, and then follow our normal routine and send a response to the client? Well, before we jump into learning an actual database, we are just going to learn about databases in general. We're going to segment these into two different types to talk about their some main differences and comparisons. But the one that we will end up using for the purpose of this course is MongoDB. And we'll talk a little bit about why. But just know that you're going to run into all types of databases in the wild and jobs. So learn one, and then you can learn another. All right. So in databases, we can segment them, if we're doing this broadly here, but we can segment them into two different major types, relational and non-relational. So when we think relational, we're thinking things like SQL, Postgres. And when we're using non-relational, we're thinking of like MongoDB and other hybrids of that. So we're not going to be using relational, but let's talk about it so we have some vocabulary we can think of, what they're called, how they kind of work, how to visualize them. So in relational databases, we're going to imagine we're creating a to-do application here with user authentication. So we're relating a user to their to-dos. And how does that work in a database? So first, in SQL, all data is stored in tables. So we would make a table for users. And if you're thinking like Excel spreadsheet, you're right. That's basically what you can visualize here. We make a table full of columns and rows. Okay, little table here. Now each column represents a key of data that we're holding for the user. So maybe this would be their name, their age, something else. And when we're creating, user number 1 or user number 2 or user number 3, we would make sure they have a name, they have an age, they have this data, and so forth. A nice thing about relational databases is this is strict. When we say all users must have a name and age and this, we have to fill in those rows when we are creating the user. There can't be any empty cells. So let's say this user didn't give us their age, we'd still have to fill it in with something like null. This user didn't give us their age. So now we have 3 different users in our database. Now we talked about this, and databases will give it to us. How do we identify user number 1 versus user number 2 versus user number 3? And that is through the ID. Now, in relational databases, this is known as the primary key. I'll say PK for primary key, but this is vocabulary for SQL. What it is an ID. So here's an ID of, some random letters, numbers, what have you. So primary key, this is the ID. Okay, so now we have this user table. Well, then we need to make a to-do table, what each to-do should look like. What data does every to-do hold when we create one, and what can we expect to get when we get them? So we create another table here, and we say everyone has a title, a description, a price, and then its own primary key. So we fill these in as we're creating to-dos. The primary key, or the ID, is given to us from the database. It generates a random unique identifier for each item. And again, remember, no empty cells. SQL enforces this by default. You have to do it this way. All right, so now let's say people are using our application. We have hundreds of a couple users. We have thousands of to-dos they've created. How does an application know? Think, like Instagram. You can go to your profile and see just your images, but you can also go to the public page and see everyone's image. Somehow, user number 1 needs to be related to the to-dos they specifically created. So how do we generate this relationship? Well, in relational databases, we would give the ID of one to the other. Before we do that, let's talk about database relationships, the 3 major types you're going to run into. So we're going to say DB relations here, relationships. So the first one we have is a 1-to-1. Then we have 1-to-many. and then we have a many to many. And let's think of an example of each of these so we can visualize what this means. So one-to-one. What is something in real life maybe that you relate to and it only relates to you? And I'll give you this first one to kind of get the ball rolling here. Think of you and your social security number, right? You have a social security number and your social security number is only registered to you. That is a one-to-one relationship, and that's how we'd visualize it in a database. One-to-many is what we've got going on here. Users to to-dos. So I'll say user to to-do. Because a user may have many to-dos, but each to-do will only belong to a single user. So one-to-many. Then lastly, we have many-to-many. You can think of this like an e-commerce store like Amazon. A user could buy a product and another user could buy that product. So products can be bought by multiple users. Multiple users can buy the same product. So I'm going to say user to product, or prod for short here. All right, so those are the main relationships we're worrying about. And again, what is the relationship of a user to their to-dos? That is a one-to-many, the user being the one, the to-do being the many. And this is important because we need to know, how do we reference who owns what in our database? How do we keep a record of that relationship? Well, with one-to-many, it's kind of the easiest one to figure out. The ID of the one is always given to the many. All right, so the ID of the user should be given to the to-do. We don't need the user to maintain an array of IDs of which to-dos they own. As long as we say every time we create a to-do, we give them a title, a description, a price. The database will give it a primary key or an ID. And then we'll make sure it also has one other cell here. And what this cell is the foreign key, or the foreign ID, the ID of who in the database this belongs to. So we'd fill this in for each to-do. And let's say this first to-do was created by our first user. So this ID, this primary key we see here, would be given as the foreign key to this to-do. And let's say user number 1 also made to-do number 2. Okay, then we'd also give that same ID to this to-do. Now let's say user number 3 made to-dos 3 and 4. So that user's ID would be the foreign key of this to-do, and this user's ID would also be the foreign key of this to-do. And why this is nice is when we go and search our database, we can say go find all to-dos who have a foreign key that matches this user's ID. And instead of giving us all 4 of these at once, it'll only give us the 2 who has a foreign key that matches. It's kind of just like using a .find on an array in JavaScript, or a filter. Go find all the ones that match this criteria, that have a foreign key, a foreign ID that matches this user's ID. Now this is very, very basic Postgres SQL. There are many other types of tables you may have to make. For example, a many-to-many relationship, you'd actually make a separate table, something called a joint table. And all it would be doing is saying, this is a user's primary key, this is a product's primary key, and that way we could relate multiple to multiple. User 1 bought product 1. User 1 also bought product 2. User 2 also bought product 1. User 3 bought product 1, and user 3 bought product 2. And notice here, we're getting a many-to-many relationship. Many users can buy the same product, and the same product can be bought by many users. All right, so that is SQL in a nutshell. A very, very small nutshell. It's a lot more to learn, but being able to visualize it's the first step. Now, how does that differ from what we're going to learn? Non-relational, MongoDB. Well, MongoDB, one of the reasons we're choosing it is barrier to entry. You're learning JavaScript, so MongoDB is going to be more intuitive just by default, because the way that it orients data is not through tables, but through objects, and we understand objects. So that's one of the reasons we're using non-relational. So let's simulate this same effect, users to their to-do, but in non-relational terms. So in in non-relational, we don't have tables, we don't have cells, or we don't have rows, tables and rows, rows each individual item. A table is all of the items together. What we have in non-relational is we have collections and we have documents. And when you think collections, think array. When you think documents, think object. So a collection would be our table. All of the users is the user collection. A document is a single row, a single user. So how do we create this data? Well, for our user, we'd say, let's make a user, and we'll call it something like a model. And we'll declare it as an object, of somewhat like looking like an object. And we get to give it key value pairs of what does every user in our database look like. Well, every user in our database should have a name, and it will be saved as a string. And each user in our database should have an age. It'll be saved as a number. And we'll literally write this. We'll say, it's just like a blueprint, almost like a constructor function. We're saying, this is the blueprint to follow when you're creating a user. They'll have a name that's a string, an age that's a number. The database will give them an ID, which in MongoDB it's called an ID, not a primary key. So _ID is the MongoDB convention, and it'll just be a random string of characters. And that is how we declare our user collection. And then every time we use this, we'll be creating new user documents that are all compiled into the same collection. All right, so with to-do, we declare another model, another blueprint of what our data is going to look like if it's a to-do. We'll say each one, has a title, that's a string, and maybe a description and all that. And eventually it'll also get its own _ID that's a random string of characters. All right, so now we're to this point where we have our two collections set up. So how do I declare this one-to-many relationship using MongoDB? Well, fortunately, these rules apply the exact same, whether you're using relational or non-relational databases. So for following this rule, the to-do needs the ID of the user. So what we would say is the to-do will have another property, and we can call these whatever we want. They're just keys, object keys, but we'll say every to-do will have a .user, and what it will be is the object ID from another object in our database, and that is where we would reference the ID of the user. All right, so this is the primary key or the primary ID of the to-do. If we're talking MongoDB terms, it's just ID. And user is the foreign key. It's the ID of the thing that this belongs to. So this to-do object ID should reference the user's ID that made it. So as we create users, as we create to-dos, we'll have two different collections in our database, two different arrays of objects. And if we need an individual object, we're referencing a single document, one object that references a user or a to-do. All right, so this is very high level entry point to MongoDB. But again, one of the main reasons why we're choosing it is barrier to entry. Objects are intuitive after you learn JavaScript. But let's talk about one thing that MongoDB doesn't do for us that something like Postgres would. And that is enforcing data. Remember when I was talking about tables, if they don't give us a value, we still have to give it a value. MongoDB, very loose. If we want to give this user anything we want, we could. If all we're using is MongoDB, we could say this user has a .name and another user has a .first name, and there's no consistency, which is bad data altogether. You can't loop over that and do the same thing to it. So we don't use MongoDB just by itself. We use it to store the data, but we're going to use something called Mongoose, because Mongoose enforces rigidity. So in Mongoose, that is actually where we're going to be declaring these models. Every user should have a name and age. Every to-do should have a title. Mongoose enforces that and will throw errors if we're trying to give it bad data, somewhat simulating exactly what SQL does. So we're going to start learning, in the further lessons here, we're going to install MongoDB, and then we're going to use Mongoose to start interacting with it. But we're going to need both to make our database work. All right, so again, high-level entry point to databases. If you're interested, definitely look more online on SQL and Postgres. It really isn't too hard to learn, especially once you learn MongoDB. A lot of the things are shared between these two as far as how you look up data. So learning one, just like learning JavaScript makes other languages easier, learning MongoDB will make learning something like Postgres easier. All right. So try to internalize this as best you can. Get used to these words, document collection. I'm going to be using them a lot. Models, Mongoose, MongoDB. And when you're ready, let's move on to the next lesson. We'll see you there.